So as I mentioned, today is a review of some algebra. And the algebra that we're reviewing here is some algebra that we're going to have to use going forward. I've tried to avoid these kind of equations and these kind of problems in the equations that we've looked at so far. But with what we're going to look at this semester, we're going to need to have these kinds of equations. Plus, I think it's good practice going into next year that you start to see these kinds of equations and solve these kind of equations. Will set you up better for Algebra 2. So before we go into actual equation solving, we're going to look at some of the background behind solving those kinds of equations, and that is extending out distributing. So as a reminder, what I mean here by distributing, I'm just going to use numbers so that it'll be easier on you. What I mean by distributing is that if I have something like 3 times 4 plus 5, right? What distributing says is that I could take this and combine these. 4 plus 5 is 9, times 3 is 27. However, I could also, what distributing says is that I can also write this as 3 times each of these pieces. So I can also write this as 3 times 4 plus 3 times 5. And that's the same thing. I'm going to give me the same answer. 3 times 4 is 12. 3 times 5 is 15. And 12 and 15, hey, look at that. It's 27. That these will both give me the same thing. Both ways of doing this will give me the same answer. Geometrically, because this is geometry, and I showed this at the beginning of the year, but geometrically you can visualize this as being rectangles. So for example, I can give this piece here is 3, this piece here is 4, this piece here is 5. And remember that area of a rectangle is length times width or base times height, depending on how you think about it. So area of a rectangle is base times height. Well, you can either find this entire area by saying, well, the entire base is 9. This part's 4, this part's 5. So the entire base is 9, and then times my height is 3, and 9 times 3 is 27. Or you could also find this area by saying, well, I have this small rectangle in green, and then I have this other rectangle in blue, and I can take that green area and blue area and add them together. That'll give me the entire area. And that's what distributing says, because here is how I would find my green area. Here's how I would find my blue area. And then my entire area is the part that's at the top, taking the 4 plus 5, combining it together, and then multiplying by 3. So we think of this more in terms of algebra, but you can also think about it in terms of geometry. The geometry says that if I take these smaller rectangle areas and add them together, I get the entire rectangle area. So that's what we're going to be looking at, is this idea of distributing. But we're going to distribute, when we distribute, we're going to distribute across 2 terms at the same time. So in other words, we're distributing across the x plus 5, but the thing is that we have 2 different terms happening here. We have an x that we need to distribute across the x plus 5, and then we also have a 2 that we need to distribute across the x plus 5. So we're going to need to distribute both of those terms. So I'm going to start here with an x. We're going to multiply it by x plus 5. Now I'm going to go slow here, especially on this first one, just to make sure that we all have it here. So we're going to start with, we have x times x. We're starting with x, distributing across the x plus 5. We have x times x. And x times x is going to be x squared. That's what squaring is. I just want to remind you of that because some people will write it as 2x. 2x is doubling. That's something different. If you're ever not sure, think about it with numbers. If I have 5 times 5, that's what 5 squared is. 10 times 10 is 10 squared. So x times x should be x squared. 2x we would get by adding. We would take x plus x, and that would be 2x. Right? That's what doubling is adding the same thing together twice. If I have 5 plus 5, that's 2 times 5. If I have 10 plus 10, that's 2 times 10. But if I have 10 times 10, that's 10 squared. So that's why when I have x plus x, it's 2x. If I have x times x, which we're going to keep seeing today, if I have x times x, that's going to be x squared. So that's going to keep coming back today. And that's what we'll wind up with on these problems is this longer chain of terms that have an x squared in it. All right, but let's keep distributing here. We have x here times 5. X times 5. Well, they're both positive, so that's going to be a positive. And then we have x times 5 is 5x. So that is distributing my x across my x plus 5. Now, we have a 2 here that we need to distribute. We have a 2 here that we need to distribute. So I have a 2 here times x. That's what I'm going to distribute across first. 2 times x is going to be 2x. And then, finally, I'm going to distribute the 2 over to the 5. We have positive 2 times a positive 5 is a positive 10. So that's all multiplying that's going on there. And just one quick thing to remember is that if I have a number times x, that we always write that it's just standard so that it gets less messy to write it as the number first and then the x. So that's why when we did x times 5, I just switched that around and made it 5x. So finally, what we're going to do is we are going to take any like terms and combine them together. So if I have some x squareds that I can put together, I'm going to put them together. If I have some x's that I can put together, I'm going to put them together. If I have just some numbers that I can put together, I'm going to put them together. Usually, that'll involve taking the middle terms and putting them together. So on this problem, I have the x squared is that first term, so it's still going to be an x squared. I have this plus 10 at the end. It's still going to be a plus 10 at the end. In the middle here, though, I have a 5x and a 2x that I can combine together to be a 7x. So the first term stayed the first term, the last term stayed the last term. It's that middle term that changed. That 5x and the 2x in the middle got put together. 5x plus 2x is 7x. Now, what we'll eventually get to, where we'll eventually go at the end of this week, is that we are going to do this in the reverse direction as well. So I'm showing it to you in this distributing direction, but eventually what we're going to do is that I'm going to show you, here's what the answer was. I have x squared plus 7x plus 10. How did that start originally? Well, how it started originally was x plus 2 times x plus 5. And that's what you'll be able to tell me by the end of this week. Is you'll be able to look at this thing, the x squared plus 7x plus 10, and you'll be able to work backwards to tell me, oh, that must have been x plus 2 times x plus 5. So that's where we're headed. And as we go, I'll kind of point out patterns that might help us see that that's to help us when we go to working backwards like that. All right, let's continue on. I'm going to do one more example and then we'll pause for questions here. We have x plus 3 times x minus 4. So once again, we're going to distribute each piece separately. We're going to start by distributing my x. We're going to take the x and distribute it across the x minus 4. To do that, we have x times x here is x squared. Here we have x times a negative 4. This is another thing about these. Keep a close eye on your signs. That's the biggest thing that people miss, is that they lose track of their negative signs. So since this is a minus 4, we need to keep in mind that this is going to get multiplied by negative 4 and not just 4. The sign goes with it. So we have x times a negative 4 is a negative 4x. Now that we've distributed the x, we're done distributing the x. Now we need to distribute the 3. Take the 3 and distribute it across my x minus 4. So we have a positive 3 that we're distributing here. So we have a positive 3 times x is a positive 3x. Then at the end here, I have a positive 3 times a negative 4. Careful here. Positive times a negative is going to be, positive times a negative is going to be negative. And then we have 3 times 4 is 12. And so we'll finish that off by taking those middle terms and putting them together. Because the x squared doesn't have anything to go with it, so it stays x squared. The minus 12 doesn't have anything to go with it, it stays minus 12. But I have a minus 4x plus 3x that can be combined together. So we have a negative 4 plus 3. My negative is outweighing my positive, so it's going to be minus 1x, which we just write as minus x. We're going to do a couple more examples, and as we do them, I want you to start looking for kind of patterns. Where is this minus 12 coming from? And how can I just look at the minus 12 and know that, and know something about what this will look like? How can I look at that x squared and know something about what this will look like? Where does this minus x come from? And how can I use that to tell me what that'll look like? We are going to start by distributing the y. And then once we've distributed the y, we're going to distribute the 4. So we're going to take the y and distribute it across. We have y times y, and y times y is y squared. Again, y times y is y squared. So this is going to be a y squared. Then I have a y times a positive 1. So that's going to be positive 1 times y. We just write as y. Then we're going to distribute my 4 across the y plus 1. So I'm taking my 4, multiplying it by each piece there. We have 4 times y is 4y. And then we have 4 times 1 is 4. Remember, that's all multiplying. Then we can take all of our pieces and put them together. So I still have a y squared here, doesn't go with anything else. I still have a plus 4 here at the end, doesn't go with anything else. But I do have a positive y plus 4y. Remember that the positive y is a 1y. So I have a 1y plus 4y is 5y. And there's our answer. Next one. Remember I said keep an eye on your negative signs. This is where people start to lose track of negatives, so watch this one closely. First of all, we're going to start by distributing a z. Again, just because it's a different variable than x doesn't mean we're going to do it any differently. Okay, so we're going to start by distributing the z. So we have z times z, and we know that z times z is z squared. So z times z is z squared. Z squared. Then we have a z times a positive 6, so that's going to be positive. Z times 6, we're going to write as 6z. All right, here's where we need to be careful. What are we distributing here? Because it's not 2. Why do I say it's not 2? It's negative 2. So all these pieces are going to get multiplied by negative 2. So make sure that negative comes with it when we talk about that multiplying. Here it comes. Negative 2 times z. If it's negative 2 times z, that means it's going to be a minus 2z. And then we're still distributing a negative 2, so it's going to be negative 2 times a positive 6. Negative 2 times a positive 6 is going to be negative 2 times 6 is 12. So we had negative times a positive was a negative. 2 times 6, 12. And now let's put those together. We have a z squared here that's still a z squared. We have a minus 12 here that's still going to be minus 12. And then these middle terms are going to get combined together. I have a positive 6z minus 2z is a positive 4z. The positive 6 outweighed the negative 2, so it's stayed positive. All right, we're going to do one more here, but before I go on, I want to point out, I said to watch out for patterns. So I want to point out some of those patterns that you'll see. First of all, the z squared and the y squared and the x squared, where did they come from? They came from the very first thing I multiplied together. So this first term paired with this first term. The y times y was y squared. The z times z was z squared. This x times x was x squared. The last term, the minus 12 and the plus 4, they came from multiplying those very last terms together. So I have a positive 4 times a positive 1 that was a positive 4. I have a negative 2 times a positive 6 was the negative 12. I have a positive 3 times a negative 4. That's how we got that negative 12 at the end. So grouping that last term with the last term. So both of those came from multiplying the first pair and multiplying the last pair. So my middle term came from those pieces in the middle. And notice, this is the important part, notice that the middle term came from combining the two pieces in the middle together. We had a 6z minus 2z was 4z. We had a 1y plus 4y was the 5y. We had a negative 4x plus a 3x was a negative 1x. Because remember, I said I'm going to ask you to look at this final answer and tell me where it came from. You're going to look at this and say, oh, this was x plus 3 times x minus 4. And the pattern that I want you to spot here and to see, and if you get nothing else from today, this is the important part. The first part and the last part of this, the z squared and the minus 12, came from multiplying. Came from multiplying in that first step. Z times z, negative 2 plus times positive 6. They came from multiplying. But the middle term, this is the important part, the middle term came from adding. It came from combining these middle pieces together. This 4z came from adding 6z and negative 2z. This 5y came from adding the y plus 4y. So that means that the terms at the end come from multiplying. The term in the middle comes from adding and combining together those two pieces in the middle. So just keep that in mind for when we get there at the end of this week, because that's going to be a key part to what we're going to do. All right, let's look at one more together before we end up here. We're going to start by distributing my r, multiplying that across, and then we're going to distribute this. First term, oh, it's a little bit different this time. We have r times 2r. And if I have something like that going on, a lot of times I like to treat the numbers and the variables separately. Remember, it's all multiplication, but I'm going to treat those numbers and those variables separately. So I'm going to have, I'm going to start with the numbers. What number is out in front of here? It's a 1, right? If there's no number out in front of the variable, it's a 1. So number-wise, I'm multiplying 1 times 2, and 1 times 2 is 2. Variable-wise, what I'm multiplying is I'm multiplying r times r. And r times r we know is r squared. So 1 times 2 was 2. R times r was r squared. So that's how I wind up with 2r squared, all multiplied. Then we have r times negative 1. Keep the sign with it. R times negative 1 is negative 1r. So I'll just write it as minus r. Now I'm going to distribute the other piece, but I'm not distributing a 5, I'm distributing negative 5. So I'm taking negative 5 and distributing it across. So I have negative 5 times 2r. So again, treating the numbers and the variables separately, I have negative 5 times 2 is a negative 10. And then the variable, I just have one of the r's, so I just have r. So minus 10r. And finally, I have, this is where we need to be careful of our signs, I have negative 5 here times a negative 1 here. So negative times a negative is a positive. And then our 5 times 1 is 5. So finally, what we're going to do is we're going to combine those together. So I have 2r squared, stays the 2r squared as the first term. The plus 5 stays the plus 5 as the last term. So the thing that changes is that my middle terms get put together. I have a negative r minus 10r. Remember, this was a 1 out in front. So I have negative 1 minus 10. If I have a negative 1, subtract 10, I get more negative. If you take a negative and subtract, you're going to get more negative. So I have negative 1 minus 10 is a negative 11r. So what I want to see here before we start tomorrow is the rest of the problems on that front page done. So 1, 2, 3. Those 3 problems done before we start tomorrow.